Okay, this was on page 26. This was your warm-up. So for problem number 1, you've got 8x, you've got 55, and you've got 85. Who wants to tell me what they got for their answer? David? Huh? 5? Okay, anybody get anything different than 5? What kind of angles are we seeing here, guys? It's not supplementary. See, supplementary means that they would have to have these adjacent to each other, right? Combined together, they would form that straight line. This is missing, though. Okay? But, if you take a look at it, you technically have 2 parallel lines, right? You have a set of 2 parallel lines, and when those 2 parallel lines intersect, they form vertical angles. This was a trick. The combination of 55 and 85 together will form the large vertical angle to 8x. So 55 and 85 combined together is going to give you 140. So that means this entire angle is 140. So we can create a vertical angle set where 8x is congruent. What does congruent mean again? Equal. Where 8x is congruent to the combination of those 2 angles. So it was a trick. It was a trick question this time. So 8x is going to be equal to 140. So one-step equation. One-step equation, what is the first step? The inverse operation. Let's go with con. Con, what is the inverse operation to perform here? It's a one-step equation. How do we solve this? Okay, well, let's walk through it because you're not clueless. You know how to do this. What operation is 8x? When they're side by side, what operation is 8x? Multiplication. So what is that inverse operation to multiplication? Leo, you're not con. The opposite of multiplication is what? Division. So we want to go ahead and divide both sides by 8. We're going to divide both sides by 8. So remember, when we divide, you're not getting rid of the value. The value just becomes a what? Leo. When we divide, what does this value become? Leah. That's understood. 8 divided by 8 is? What's 8 divided by 8? 1. It's Monday. Where's your coffee, guys? Where's your coffee? It becomes a 1. So remember, we talked about it before. When we were doing the opposite with addition and subtraction, that cancels out because those become 0 pairs. This does not cancel out. It simplifies and just becomes a coefficient of a 1. Do we have to write that 1? No. So remember, if you get stuck, you can always refer back to the board. The invisible math board will tell you you don't have to put the 1 there. It's automatically there. It also has another way of writing multiplication. If you forgot the different ways of writing multiplication, in the back it shows you that when you have 2 that are side by side, that technically is multiplication. You don't always have to have, a multiplication symbol in between. Don't forget to utilize that invisible math board. It also has, next to it's got that equations board. So if you forgot your inverse operations, you've got the how to solve all equations back there as well. Okay? And then 140 divided by 8. Kimberly, what is 140 divided by 8? 17.5. Good. It's okay to get a decimal. A decimal is still a value. Okay, remember decimals are still numbers. 0 is still a number. Okay, all these values are still okay. All right, for problem number 2. Problem number 2, before we begin, we need to identify the relationship that exists here. Let's go with Jair. What relationship is formed when we see that L? The 90-degree angle. Does anybody remember the term for that? Sarah? Complementary. Here's a fun way that one of my students in previous years came up with how to remember complementary is 90 degrees. A 90-degree angle is also called a right angle, right? So if I say, gosh, you are always right, I'm giving you a compliment. Complementary angles are always right, okay? So you got that compliment there. Another way that some of my students came up with how to remember, if you're thinking alphabetically, C, complementary, comes before S, supplementary. Right? In the dictionary, C comes before S. That means 90 comes before 180. So 90 pairs with the complementary, 180 pairs with the supplementary. Come up with those mechanisms to help you remember that. Okay? So we know that this is a complementary set. It forms that L shape, that 90-degree angle shape. So we know when we create our equation, it has to be equal to 90 degrees. Now this, I threw this one in here because we're going to be working on these today in Pride Time, in our extension time, on combining like terms. But I want to give you guys a preview of it before we get into our Pride. Remember last week we talked about how we could combine numbers together because they were like terms. You can do the same thing with your variables. So if I create my equation by adding these two angles together, I have 3x plus 10, and I'm going to add that with the angle 2x plus 5. Like terms are not just number terms. Like terms are not just your number terms. Like terms are also variable terms. If they have an identical variable raised to the same power, means that they are both raised to the same exponent, you can combine them together. So we've got 3x and we've got a 2x. I know 2x is positive. Who remembers, how do I know that 2x is positive? Leo? Because there's an addition sign in front of it. Remember, the sign in front indicates what type of integer it is. So I'm going to include that when I put a box around it. These are two like terms, 3x and 2x. We also have like terms of positive 10, so I'm going to put a green circle around that, and a positive 5. We can rewrite these statements so that our like terms are side by side. So 3x plus 2x. Let's first focus on simplifying that. If we've got 3x and we're combining it with 2x, Caden, what will that give us? 3x plus 2x. 5x. Very good. Don't forget to keep the mask over the nose the whole time, okay? We've got 5x. Okay, now we focus on our numbers. We've got a positive 10 and a positive 5. Remember, these are our constants. When we combine those together, what is that going to give us? Briley. 15. Positive 15. Don't forget, we have to indicate it's positive because this is an expression. Can I just put 15 here and be done? Yes or no, guys? Why not? Why do you think, David? Why can't I just put 15? What's missing here? The positive sign, because later it's now going to be an operation. right? We have to know what operation is there. Since it was positive, we have to put that positive or plus sign to show that it's an addition operation. If it was negative, we would use that negative sign as a minus sign to show it's a subtraction operation. Okay, and all of this is still equal to 90. You have now just taken a multi-step problem, right? We talked about multi-step. We focused last week on distributive property for multi-step. This is also multi-step, combining like terms and simplifying what you can before you solved. Once you've simplified, you have it down to a two-step equation. We know how to solve two-step equations. What is the first inverse operation that we have to do when solving these two-step equations? Let's go, Amy. What's the first inverse operation we're going to do? Subtraction. So we are going to subtract 15 from both sides. Now the 15s are going to cancel out. They are zero pairs, right? A positive and its negative counterpart are zero pairs. They will cancel out. But what you do to one side, you have to do to the other. We're left with that 5x is now equal to, very good. Our last inverse operation, Maria. Divide by 5. Good. And Maria, what do you get when you divide both sides by 5? 15. So x is equal to 15 in this case. And guys, when in doubt, you can always take your answer and substitute it back in. You can do 3 times 15 plus 10, and that should give you 55. You could then do 2 times 15 plus 5, and that should give you 35. And then when you add 55 and 35 together, it gives you 90 degrees. You can always check to make sure you've gotten it correct. That's the wonderful thing about algebra. It's self-checking. Okay? Let's take a look at our last problem, number 3. So for number 3, what type of relationship exists here? What angle relationship is this going to be? Let's go, okay, Aiden, we'll go with you today. Supplementary angle set. Okay, it forms the straight angle, and straight angles are equal to how many degrees? 180. 180 degrees. So when we combine these together, remember the sum of the angles should equal 180. So we're going to take this, we're going to have our 6x minus the 22, and we're going to add it with the 2x plus 58. And that's going to equal our 180 degrees. Okay, it's exactly like what we just did with our last problem. You have to combine your like terms. What's one set of like terms that I have up here, Leah? 6x plus 2x. Very good. So we have 6x plus 2x. We know it's positive because it's got the plus sign in front. We can go ahead and work out 6x plus 2x. What is that going to give us, Nina? 6x plus 2x. Here, I'll zoom in so you can see it a little bit better, babe. Yeah, put your glasses on. 8x, good. So we get our 8x. Then we've got our constants. What are our two constants up here, Devin? Sorry? Oh, I'm sorry, what? Are you sure it's 22? You know 58. Are you sure it's just 22? Aaliyah, help him out. Negative 22. Why is it negative, Devin? Because of the subtraction sign, okay? Subtraction sign in front is now stating that that is a negative value. If you had just put 22 and 58 and added those together, you would have gotten 80. But that's wrong because it's a negative 22 and a positive 58. That changes the answer entirely. Be mindful of the operation in front. The operation in front will indicate the kind of value. So negative 22 plus 58. Eric, what is negative 22 plus 58 going to give us? 36. Positive or negative? Positive. So what do we need to put in front? A plus sign. Good. We have to put that positive or plus 36. This is all still equal to 180. All right, we are now down to our two-step equation. Our two-step equation, let's see here. Who have I not called on? Edgar. Edgar, what is our first step to solving? Very good. Subtract 36. So we're going to subtract 36 from both sides. Remember, the 36 is because it's an addition and subtraction. That is 0 pairing out. We're now left with 8x is equal to 144. Our last step, Bonnie, divide by 8. Okay, divide by 8. The 8s will simplify, and we're left now with x is equal to what? 18. Okay. So these three angle relationships were from last week. And remember, I told you that we actually have more than just these three kinds of relationships. So what we're going to be learning about today is how transversals can create angle relationships too. So a transversal is when we've got two sets of parallel lines being cut by a single line called a transversal. Go ahead and turn your notebooks to page 27. All right, so for transversals, like I said, a transversal is a line that is going to slice through or cut through a set of parallel lines. So it's a line that cuts through or intersects. It's going to intersect through a set of parallel lines. And remember, parallel lines are lines that do not touch. Parallel line examples are things like railroad tracks. That's a set of parallel lines. If you look on the wall, the sides of each of the bricks can be considered a parallel line if you're looking at each brick individually. The sides don't intersect with each other. The top and the bottoms don't intersect with each other. Those are considered to be parallel lines. Here on our notebook paper, we have sets of parallel lines. Okay, so transversals are lines that are not going to be running side by side with them. They're actually going to be cutting through, slicing through them. Okay? When we cause that slice, we create these angle relationships called alternate angles. Alternate interior, alternate exterior, and then corresponding. All of the angles that are created through a slice of a transversal create congruent relationships. Okay? So that's really important for you to know. Let's go ahead and write the definitions for each of the types though. Alternate. Another word for alternate is opposite. Another word for alternate is opposite. And then interior, what do you think of when you hear interior? Sarah? Inside. So an alternate interior means opposite inside. We'll show examples of those in just a second. So these are inside the parallel lines. They run in between them. And they are on opposite sides of the transversal. one of the angles might be on the top right, while the other is on the bottom left. They are on opposite sides and ends of the transversal. Then you've got, again, alternate, opposite, exterior. What does the word exterior mean to you guys? Eric? On the outside. Interior is inside, exterior is outside. So alternate exterior is outside the parallel lines. And again, they're on opposite sides and ends of the transversal. And then our last relationship that we're going to talk about is corresponding. And with corresponding angles, got my purple, these are going to be considered to be the same position in relation to the transversal line. But one of them is interior while the other is exterior. All right, so now I'm going to give you a nice, lovely, large example. So we've got our set of parallel lines. Again, it's nice that we've got them set up already on the paper. And a transversal is just a line that is going to slice through the parallel lines. So this line would be considered our transversal line. So starting with our alternate interior angles, we'll go ahead and say that this is angle X, this is angle W, this one is angle Y, this one is angle Z, and then down here we'll say that this is A, this is B, this is D, and this one's C. Okay? Make sure you have them in the same position that I do. So for our alternate interior, interior means it's inside of the parallel lines. So that would be roughly between the parallel lines here. So we have 4 angles that are in between the parallel lines. We've got Y, Z, A, and B. So if I start with angle Y, angle Y is interior, and now I need to find an alternate, which means it's going to be on the opposite side, of the transversal. So right now Y is at the top left side, right? It's at the top of the transversal. It's on the left side of the transversal. I need to have the opposite. So what's the opposite of top? Bottom. What's the opposite of left? Right. So I need to go to the bottom and to the right side. So that would be angle B. So angle Y and angle B are alternate interior. I'm going to go ahead and put a single slash through the angle. The reason for that is because I have another set of alternate interior angles. Angle Z and angle A are also alternate interior angles. So I'm going to put a double slash inside. That lets me know that these two angles relate to each other and these two angles relate to each other. Does that make sense? Does Y relate to A? No. Y does not relate to A. Y is only related to B as alternate interior. Z is only related to A as alternate interior. Okay? Our alternate exterior, again, they're on the outsides of the parallel lines. Okay, so they're branching away from the parallel line. If we start with angle X, who can tell me which angle is going to be its alternate exterior counterpart? Ethan? C. Angle C is going to be its alternate exterior buddy. So I'm going to put a single line in there in blue, so I know that these blue singles relate to each other. And then I've got W relates to D. I'm going to put double lines. W relates to D. They are also alternate exterior angles. Okay, then my corresponding angles. There's a lot of corresponding angles here. X. X corresponds with A. They are on the same side of the transversal line, right? They're both on the left side of their transversal line. They're both above their specific parallel line. They're both above their specific parallel line. One of them is exterior. X is exterior. The other is interior. A is interior. These are corresponding. So if you focus on just these clusters, this is an individual cluster, this is another individual cluster. If you focus on those individual clusters and I were to take this cluster and slide it on up here, A and X would overlap. Does that make sense? What would W overlap with? B. What will Y overlap with? D. And Z will overlap with C. Okay? So W, I'll put a double line, and B gets the double line. Z gets a triple line. C gets a triple line. Y gets 4 lines. And D gets 4 lines. They correspond to each other. And again, it's important to know that alternate interior angles are congruent. Alternate exterior angles are congruent. Corresponding angles are congruent. Okay? So all we've created here is a set of total congruency. Now, an important note to make. If you only have one transversal, because you can have more than one transversal, but if you only have one transversal, then technically you only have 2 angles. Oops, I misspelled it. Again, if you only have one transversal intersecting a set of parallel lines, you technically only have two angles. You've got all these acute angles. All of your acute angles are congruent. So that means all the acute angles are the same measurement. X, Z, A, and C, they're all the same. Okay, and we know that because if X and C are the same by being alternate exterior, X and Z are the same because they're vertical. They're vertical angles, which means Z and C are also the same. Plus the fact that those are corresponding. Okay? So you've created a set of acute angles that are all equal to each other. And then you also have a set of obtuse angles, 4 obtuse angles that are all equal to each other. And then something even cooler, the acute plus the obtuse will equal 180 degrees. So any acute angle up here added with any of the obtuse angles, it'll equal 180 degrees because it forms a supplementary set. X and W is supplementary. Again, this only is true if you have a single transversal line slicing through a set of parallel lines. When you're done copying that, go on to the next page. Alright, page 28. I want to know the angle measurement. So if angle E is equal to 114 degrees, and I'm giving you the following transversal set. Angle E is equal to 114. I want you to tell me the measurement of angle A. And how do you know? What is its relation? What is A's relationship to E? And what will A equal? I want to know angle D. What is angle D's relationship and what will it equal? And then we'll even say angle H. Yeah, angle H. What is its relationship to E and what does it equal? Okay. So let's start with angle A. So we know the measurement of angle E. We know the measurement of angle E. So here's E and here's A. What relationship are E and A? Leah? Corresponding. And what will A equal? Not 90. 7. Well, what's E and A? If you know E, do you know A? 114. Corresponding, they're equal to each other. Remember I said equal relationship here. So E and A are corresponding. A corresponds. It's corresponding with angle E. So that means angle A equals 114 degrees. Corresponding angles are equal. Okay? Angle D. So how do angle E and angle D relate to each other? What is their relationship, Aiden? Huh? Alternate interior. And what color did I do that in? I did alternate interior in pink. They're alternate interior. E and D are alternate interior angles to each other. Alternate interior with angle E. And again, alternate interior angles are also equal, so that means angle D also equals 114. Okay, so we know angle A is 114. We know angle D is 114. How does H relate to E? What relationship is E and H? It's not on today's notes. Maria? Vertical. They are vertical. We'll go ahead and do that in orange for today. They are vertical angles. It's vertical with angle E. And like we said before, we know vertical angles are equal to each other. So H is also equal to 114 degrees. Okay? E and H. So if I know that this is 114 degrees and all these are 114 degrees and this was earlier told to me that it was 114 degrees, can I figure out what B, C, F, and G are? I know all the obtuse angles. Can I figure out the acute angle? How? Look back at your notes. The previous page at the very bottom, what did I write? All acute plus obtuse should equal what? 180. So if I know my obtuse is 114, what is that going to make all my acute angles? Not 180. 66. 180 minus 114. All of my acute angles will be 66 degrees. Okay? Let's do another example. Coming up with something funky. Angle A equals 40. So what I want you to tell me, the relationship that A and Y have, and what do they both equal? What's the relationship for angle A and angle Y? What's the relationship for angle A and angle F? And then tell me the relationship for angle F and angle G, and what do they both equal? Who can tell me what is the relationship for A and Y? A and Y. Eric? Alternate exterior. Alternate exterior. So that's going to be our blue. So angle A and angle Y are alternate exterior. And we already know that angle A is equal to 40, so what does angle E equal? It also equals 40, right? They are alternate exterior, so they are equal to each other. Okay? A and F. A and F. What kind of angle relationship is that? A and F. I'm calling someone who hasn't. Leland, you haven't answered today. A and F. What relationship is that? Corresponding. Very good. A and F. Corresponding. Again, we already know that A was equal to 40, and since they are corresponding, F will also equal 40. And now, different relationship. F and G. F and G. What kind of relationship do you think that is? Amy? Huh? They are adjacent, but what other relationship are they? David? Not vertical. If they're adjacent, they can't be vertical. Look what they're forming. Aiden? Huh? Supplementary. Good. They are supplementary. So we'll go ahead and do that in orange for here. Supplementary. Angle F and G are going to form a straight line, right? They're going to form that straight angle, so they are supplementary. Okay, so if we know angle F already. Angle F is equal to 40. So how are we going to figure out angle G? How are we going to figure out angle G? Sarah? Not divide 180 by 2. Leah? 180 minus 40. That's all you got to do. Take 180, subtract 40, and you're going to get 140. Angle F is 40. Angle G is 140. All right. You guys have IXLs. 2 IXLs posted. 1 IXL is involving identifying the relationship. So they might give you the relationship and you have to pick the angles that are that relationship, or vice versa. The second one is you solving for missing angles based off of the relationship.